because it says 20 grams of silver bromide can be formed when solutions containing 50 grams of magnesium bromide and 100 grams of silver nitrate are mixed together. How many grams of excess reactant remain unreacted? Now, I chose this problem because it has two interesting things. One, it's not giving you a chemical reaction, like a physical chemical reaction. And second, because we're gonna get the leftover, okay? I did already an exercise with the leftover, but remember, as a review, it's good that you, that you keep it handy, okay? That you have a fresh explanation of that topic. Better a fresh explanation than not having an explanation at all. That's all I'm saying. All I'm saying. So, first of all, ah, okay. It was in 11 too, that's why I didn't have a. Okay, so first of all, as I was saying, sorry, no, interesting because of two reasons. One, it doesn't give me a chemical reaction, we have to get it. And two, I need to get the excess react unreacted or leftover. So I'm going to read the problem again and I will highlight the information that is going to help me to determine the chemical reaction. It says, how many grams of silver bromide can be formed when solutions containing 50 grams of magnesium bromide and 100 grams of silver nitrate are mixed together? How many grams of excess reactant remain available? So I'm going to give you okay, three numbers of the three substances that are mentioned in the problem. What are my reactants and what is my product? To know that, we need to carefully read the word problem. So it says, how many grams of silver bromide can be formed? That is giving me a huge key to understand. The part that says can be formed is actually telling me about the result, okay? The formation, product formation. In this case, this part that says can be formed, you can say that is information about product. Okay? So, in other words, this is telling you that silver bromide is a product of the reaction. So I will start by writing the equation right here. Okay. Now, it says when solutions containing magnesium bromide and silver nitrate. Substance number 2 and 3, are they products or are they reactants?
Reactants.
They are reactants, okay? So you complete the equation by writing the reactants. MgR2 and AgNO3. Okay. Now I have a question for you. Is this reaction complete or is missing something?
We need to balance.
I need to balance. Okay, so I'm going to list all the elements that are part of my reaction. So first we'll list the metals. We have magnesium and we have silver. And then we'll list the non-metals different than the oxygen and hydrogen. So I have nitrogen, bromine, I also have oxygen. So how many magnesiums we have in the reactants?
1.
How many I have in the products?
0.
How much, sorry?
0.
0.
Okay, 0. Now, 0 cannot be. Why is that? There is a principle that I told you about about a year ago, that says that matter cannot be created nor destroyed, it's only going to be transformed. So, elements cannot just simply disappear in a chemical reaction. If here I don't have magnesium in the product, means that I'm missing one product and I need to get it. Okay, so actually this reaction is whatever I have in the reactants that produce silver bromide plus an unknown product, an unknown second product. Now, how can we get the other product? Last year's topic that was type of chemical reactions, we talked about a single replacement and double replacement reaction. Now, how can I tell if this equation is double or single replacement? Take a look. I have two elements here and I have two elements over there. So when I have two compounds, so this is one compound and this is another compound. When I have two compounds, okay, I will have a double substitution reaction or a double displacement reaction. Now for this kind of reactions, what we do is we exchange patterns, okay, which means that magnesium and silver will switch places. So if I switch places, I will have AgNO3. Sorry, I will have Ag now combined with bromine, and I also mean that also means that Mg that now is gonna be in the other side is going to be next to nitrate. That's a double displacement reaction. Now take a look. This product right here is already included here, which means that my second product has magnesium and nitrate. So my second product right here is not unknown anymore. Now you know that has magnesium and nitrate. But remember something. Atoms have valence electrons. So the valence electron for magnesium, how much is that? What are the valence electrons for magnesium?
1.
Remember that table that I gave you for ions and polyatomic ions? So magnesium, what is the charge that we use for magnesium?
2.
2 positive. Now, what is the charge that we use for nitrate?
3.
For nitrogen, is -3. But for nitrate, the two of them together, they are here in the table 2 of polyatomic atoms. Nitrate has a charge of -1. Okay, it is right here. So for the charge of -1, remember that we ignore those charges because we are not going to crisscross that kind of charge. Basically, you can ignore it. But you do have to switch the position of magnesium's charge. So it comes from magnesium and now it's going to be part of that. In other words, this compound is going to be made of MgNO3 and the 2 that is coming from magnesium. But this cannot be together like that, so that means that we need to place parentheses. Remember, this topic is called compound formation, and we have been working with this a lot. Now that we can balance, now that we have that, we can balance the equation. Is it balanced or we need to balance?
We need to balance.
Okay, so I'm going to list everything I have. 1 magnesium, 1 silver, 1 nitrogen, 2 bromines, and 3 oxygens. And in the products, I have 1 magnesium, 1 silver, 2 nitrogens, 1 bromine, and 6 oxygens. So to balance that, I will begin with my nitrogen. So I'm going to put 2 right here to balance nitrogen. Now I have 2 nitrogens, but also it changes my amount of silver and also my amount of oxygen. Now I continue. In the other side, I will put 2 in front of silver. Now my silver is balanced, but this also changes my bromine. And now it's balanced. Once we're done with the procedure, the balancing procedure, I will just copy and paste again the formula, okay? Because I need to work with this. Once I have my equation, I need to start working with it, okay? So I need to put all the information available. It says, how many grams of silver bromide? They're asking me about this product. Okay, so this is the product that I care about. How many grams? So I need to find grams, okay, of silver bromide. When 50 grams of magnesium bromide reacts with 100 grams of silver nitrate. Okay, that is information given in the problem. And they're asking me number of grams of the product. So I need to work with these 3 substances, which means I need to be working with the molar masses. So remember what I do, I work with the molar masses part, okay? I'm gonna be working with these molar masses here. Okay, so let's work with the molar masses. I have my first substance that is MgBr2. I have 1 magnesium, 2 bromines. Okay, I get the molar masses. Magnesium that has 23 or 0.305, and bromine that is 2 times 79.909. How much is this? How much is this?
One hundred eighty-four
184
point
point
180
84.12.
point 123, right? And these are grams over mole. 6.12, it's okay. Now let's work with the second substance, AgNO3. So this is 1 Ag, 1 N, and 3 O's. The molar mass of silver, that is 107, if I'm not mistaken, 0.87. Nitrogen, that is 14.006. And oxygen, that is 15.999. I'm using right now all the digits. If you use round numbers, if you use a molar mass calculator, well, they don't do that in your quiz because you need to show all the procedure. Okay. How much is this?
169.88.
Thank you. And then we finally move to the other substance, that is AgBr. 1 silver, 1 bromine, is this bromine? Yes. How much is this?
187.78.
Okay, now that you have all your masses, your molar masses here, you're gonna include it in the reaction. I like to work because it helps me to visualize everything I have. Okay, so I have 184.12 grams over mole here. I have 169.88 here, and I have 187.78 over there. Now, what comes after? I need to analyze what is given and what is requested. The problem is giving me masses. Okay, I have grams in my two reactants, and it's asking me about grams in the product, which means that I have to make a conversion from grams given to grams unknown. So this is grams to grams stoichiometry, and you know that I already gave you the path for this kind of conversions. That says grams given to moles given to moles unknown to grams unknown. It is important that you guys don't forget this path. It's very useful that you keep it handy. Now, let's work with this. It says, from grams given to moles given, you're gonna be using the molar mass of the given. Okay? From moles given to moles unknown, you're gonna be using molar ratios. And from moles unknown to grams unknown, you're gonna be working with the molar mass. Now, let's work with this. Remember, the first step here is to work with a linear reactant. So you need to work with the two reactants. You have MgBr2, magnesium bromide, and you have the other reactant that is AgNO3. So we start working with this. Mg, they are giving me, for magnesium, they're giving me 50 grams. Okay, I need to work, and I need to multiply times the molar mass of the given. Remember that I'm going to be using this. These are my conversion factors, so I can just write them in the same order. Okay, so I will multiply times the molar mass of the given, that is 184.12 grams MgBr2 that I have in 1 mole MgBr2. I will multiply times the molar ratio between the two substances. The molar ratio that I have between the given and the how many moles of magnesium bromide I have. How many moles I have of magnesium bromide? Guys,
1,
how many moles I have of silver bromide?
2,
And then I use my other conversion factor, that is the molar mass, the unknown. So in 1 mole AgBr, I have 187.78 grams of AgBr. How much is this?
101.99.
101.99. These are grams of AgBr. So let's work with the other substance. I have 100 grams of AgNO3. So the process is the same. I need to use the molar mass of the given. So the molar mass of AgNO3 is 169.88 grams of AgNO3 that are inside 1 mole of AgNO3. I don't know what happened. I lost the grams. Guys,
yes,
I don't know what's going on. I'm like confused now. Right. I lost what I wrote right here. I lost it. I don't know why. But I remember that the answer was 101.99 grams. Okay. Now I'm gonna continue working with the second part. Maybe it doesn't get blocked anymore. So the molar ratio between the unknown and the given. So how many moles of silver nitrate I have? How many moles I have? 1, 2, 3, 4.
2.
I have 2. And how many moles of silver bromide I have?
2.
Okay. And then I multiply times the unknown substance. Molar mass, 1 mole AgBr, that has a mass of 87.78 grams. How much is this? How much is this?
110.54.
Okay. So which one is the limiting reactant? Magnesium bromide or silver nitrate?
Magnesium
Magnesium
bromide.
bromide.
Okay. So this is the limiting reactant, magnesium bromide, and that's what it can be produced. Okay? So here you just write a sentence to answer that question. How many grams can be formed? Well, it can be formed 101.99 grams. So what do we do in order to get the leftover? That's the part I care about. So for the leftover, remember what I explained during the video, okay? In the leftover, you have to relate the limiting reactant against the excess reactant, okay? So you begin with your limiting reactant. The amount given of your limiting reactant are the 50 grams. So you're gonna be working on that. 50 grams of MgBr2. But you're gonna be working just with the limiting reactant, okay? Mental delay. Okay, so the procedure is the same. Molar mass given, molar ratio, molar mass unknown. So the molar mass of the given, you already know, is 184.12 grams that you have in 1 mole of MgBr2. The molar ratio. The molar ratio is you have 1 mole of magnesium bromide against 2 moles of silver nitrate. And then the molar mass of the unknown in 1 mole AgNO3, 169.88 grams. How much is this? How much is this?
92.27.
Okay, so this 92.27 grams is what we're gonna know as what we used, okay? It is the excess reactant, how much I used, okay? I used only 92.27 grams. So how can I get the leftover? So the calculation of the leftover, it's going to be like this. It's going to be the excess reactant given minus what you used, okay? So the problem gave me the excess reactant, remember that is silver nitrate, okay? This is the excess reactant. This is the limiting reactant, MgBr2, and AgNO3 is the excess reactant. So the problem gave me 100 grams of that substance. So the given is 100 grams. And I will subtract how much I used. That is what I just got, okay? 92.27 grams. So after you subtract all that, 100 minus 92.27, it gives me 7.73 grams of AgNO3. Okay guys, this is what I was saying. Sorry, I have a lot of issues. That is not my connection, I guess. So the leftover, the calculation is very simple. Is what you have in the beginning subtracted with what you use in the reaction. The process that we did before is how to calculate what we use of the excess reactant. So out of the 100 grams that the problem gave us, the reaction only took 92 grams. Okay, so the leftover is the unreactive part. So what we do is a subtraction. 100 minus what we got, 92.27, and it gave us less than 8 grams. So the leftover, also known as excess reactant that remain unreacted, is 7.73 grams.